Today we're going to be going over the family of functions. There are four main families of types of functions you will be seeing in the next few years in your math classes. We've already gone over the first one and gone over how to graph it, which is a linear function, which is pretty much just lines. So make sure you're on this page of your classwork. I believe it's the third page. It should be sideways. So center we have the word linear functions, which is a type of function we're going to be talking about. We're going to go over its general characteristics. So the family of linear functions includes functions of the form mx plus b. Again, this should not be anything new. So again, that's the general equation. And m and b are your slope and your y-intercept. They're real numbers. They're not going to be as a m or b. So again, just write this into your graphic organizer, which says linear just means a line graph. It will always produce a line, nothing else, whether it's increasing, decreasing, or constant. So when we have on the graphical behavior on the right, any line can increase, it can decrease, or it can be constant. Remember, constant means goes from left to right. In terms of maximums and minimums, since a line goes on forever, it never reaches a highest point or a lowest point, so it has no max and no min. And it's obviously not a curve, it's just a line. So make sure you pause this, write this down. I'm going to keep on going. All right, so in terms of the actual examples, just draw two XY planes. Just do a quick sketch. And we're going to draw two quick lines, one where it's decreasing, and I'm going to make the other one discrete. Remember, discrete means it's individual points that form a line. So here's an example of an increasing line that's discrete. So let's just write a general equation here. It's not going to be exact. F of x, which is your y, equals negative x plus 3. Slope is negative 1. And here's an example of an increasing line. F of x equals 2/3 x minus 1. Now, what makes the one on the right discrete versus the one on the left is the fact that it can only have integer values for x. So you cannot put in 1.5 or 2.3, its only whole number is 1, 2, 3, 4. So they're the individual points, as if we were to do a t-table, but not connect it and include everything in between. All right, so it's just general recap of linear equations. So let's get into the other three families, which are the new ones we're looking at today. Next one is a quadratic family or quadratic functions. The definition is quadratic functions are of the form f of x or y equals ax squared plus bx plus c, where a, b, and c are actual numbers. Now the key thing for the quadratic family is this piece right here. It has the power of 2. That's what makes it quadratic. So let's make sure we go talk about quadratics. They increase and decrease, or they decrease and increase. They have that U shape, so they change direction. They do have a maximum and a minimum. So they have a maximum or a highest point if it looks like that, like facing down. It has a minimum if it's facing up because it has a lowest point. So it's the opposite of what you would think it would look like. So maximum has a highest point, minimum has a lowest point. So again, maximum, we have a highest point, minimum, we have a lowest point. So that's what they mean by max or min. It has a highest or a lowest point. Now, it's a curve, obviously, it's not a straight line, it's a smooth curve. And just to throw on the left side, it definitely has a power of 2. That's what makes it quadratic. Pause if you need more time. For the bottom, we're going to draw two quick examples of quadratics. So here's a parabola that is facing downwards. Here's its equation. Notice it has a power of 2 in the equation. Here is a quadratic that's facing upwards, so parabola is going up forever. Just f of x equals x squared. Notice they both have the power of 2 on them. Next family is the exponential family. So it has to do with exponents. So if you look at its definition, the exponential family includes functions of the form a times b to the power of x, where a and b are real numbers, and b is between 0 and 1. So what makes it exponential is the fact that we have the power on the letters a on the letter b. So b will be a number like 2 to the power of x, 5 to the power of x, but the exponent is the actual variable x. So it's not like a power of 2 or 3 where the power is a number. It's the actual variable. It's a power. So exponential functions will increase or decrease. They don't do both. They either go up or they go down. They do not have a maximum or minimum like a line because they go on forever. And because they don't change direction, they have no max or min. And it's a curve. So again, just to throw on the left side, the variable x is your exponent. So that's how we can tell an exponential function if the variable is an exponent. Now for some examples, I think I have the wrong picture here. This should actually say right here exponential on it. So this right here should be exponential. So you should be on the right page either way. So let's go ahead and do some examples of this one. So an exponential is just a smooth curve that slowly grows and then it shoots off. Or it does the opposite. It comes down really quickly and then it levels out. Now the one thing about exponential functions is that they always decrease. Even though they look like they start becoming constant at the end. So like, for example, it may look like right here, this part is constant. It's actually not. It's just decreasing it's just changing very little bit, going down, but a very small amount that it's hard to see just with the naked eye. So just be aware that exponential functions do continue going downwards or upwards in both directions, even though it may be hard to tell. Here this is still going to go down forever. It's just going down very slowly or by a small amount. You can't really tell, but just be aware that it is going down. So here are equations. Notice that they both have the power of 2 on them. I'm sorry, the power of x on them. So we got to just be careful with that. Just remember, all exponential functions have the power of x. No other powers, no numerical powers. Their base is a number, but the power is the variable. That's how we can tell exponential functions. And let's move on to the last family, which is the absolute, oh, we forgot this part, where x is an integer. So again, remember the fact that we say this part tells us, let's go back. The fact that I'm saying x is an integer, that's what makes it discrete. I'm not doing every number in between, I'm just doing whole numbers. Remember, integer is a whole number, so I can only plug in 1, I can plug in 2, and so on. And last family, which is the absolute value family. And some people will call it the linear absolute value family because it's made out of 2 lines. So remember, our linear absolute value functions are the V-shaped functions. So let's get into the actual definition. The family of linear absolute value functions includes functions of the form f of x equals a is a number with the bars. Those are the absolute value bars, x plus b, and then another number on the outside plus c. Again, a, b, and c are any numbers except a cannot equal 0. Otherwise, it would eliminate your absolute value bars. So again, they can increase and decrease because it has that V shape. It goes down, then it goes up. If it's a backwards V, it goes up, then it goes down. So it does have 2 directions. So it has both behaviors. So the absolute value functions also have a max and min, just like the quadratic functions. The V shape, the U shape, very similar. So maximum if it's facing downwards because it has a highest point. So that's your maximum where it turns around. And minimum if it has a lowest point, same as before. This is our maximum point right here at the top. This is our minimum point here at the bottom. And this is not a curve, it's made up of lines. So this one is made up of straight lines, to be exact. And remember, the way we can tell an absolute value function is absolute value because it has the bars with the variable inside. And for some quick examples, draw your XY planes. Just draw that V shape. One going up. We're going to make the other one discrete, going down. So again, the one on the right says where x is an integer, it can only be whole numbers. That's why we have the gaps in between and the individual points. When there is no condition on x, it can be any real number, meaning you can plug in 1, 2, 3, negative 1.1, 0.2, 0.3. So everything in between becomes that solid line, as opposed to individual points where you can only substitute integers. All right, so that's pretty much it for the actual notes. Now you're going to go ahead and finish that last page on your handout. So good luck.